Well, good morning. Thank you all for staggering in at the early start of a 9 a.m. talk. Jim and I are going to kind of tag team this. I'm going to start out with a more general overview of what Second Life is, why scripting is important to us, and how we got to the point of looking at mono and CLI, at which point I will hand it off to Jim, who, as the person who has been unfortunately having to do that, who can talk with more expertise on that side of it. We should have some time for some demos. We actually just got up and running with the actual mono compiler for our scripting system, so we'll show you that. Hopefully compare it to the original scripting language, which should make clear why we're switching to mono. So some quick questions first. How many of you play online games or will admit to publicly? How many of you have heard of Second Life?
As of this morning, yes.
Other than today or yesterday. How many have used Second Life? Okay, cool. Just helps sort of determine how fast we're going to go through things. I tend to go really fast because you're all so smart. So if I use something you don't recognize, every field has its lingo. So if I use an acronym or something that doesn't make sense to you, just throw up your hand or yell out, hey, what is that? Throw something at me, get my attention. It's going to be a lot more fun if we're interactive. Yeah? Exactly. You're really smart, but it's early and you haven't had your coffee yet. So first of all, the world's most complete history of online game playing. So late 60s, we connected computers. We immediately started playing text games on them. Then we added graphics, and then we made the graphics look like D&D. So this is the history of online games. You are now experts. And turns out this is pretty mass market stuff, so you need to care about it. In the US, around half of US folks, if you survey them, will describe themselves as gamers. A fairly large number of people worldwide are playing persistent online games. These are games that require, say, 10, 20 hours per week of their time. And the other thing is, this is perhaps the most important one for all of us who are developing software. So if you're under 18, you're a gamer. So the age is going up by 1 year per year at this point. The other thing is, there's a lot of money being created here. Annually, the worldwide sale in intangible game items, so in other words, things that you use in the game, like an account, or in-world currency, or in games, things like a sword. It's about $1 to $2 billion US a year. So it's not as big as athletic shoes, but it's starting to be real. And the important thing in games is actually the second point. The reason people are doing this is it's a path through the game that shortcuts it, right? We talked about 10 to 20 hours a week. I bet no one in this room has a spare 20 hours a week. And so if you want to play with your friends, you may want to do things that will let you get through faster. So you go to eBay and you buy stuff. More interesting from my perspective is that much like trade in the real world is a relatively small percentage of GDP, that same impact exists in virtual worlds and online games, where the amount of value being created is many times the amount that's actually being traded. And if you do crunch all of those numbers, you get something on the order of $15 to $30 billion a year, which is interesting because that's twice the size of the entire game industry. So okay, so now not only are you experts on the history, you know everything that there needs to know about massively multiplayer online role-playing games. The world's worst acronym, but describes things like World of Warcraft. Right now, the most successful game of this type with, depending upon how you count, many, many, many millions, but somewhere between 6 and 10 million people playing. When we set out to create Second Life, we started by saying, well, okay, these more pigs are cool, but what do we do next? So Second Life is something that's a little bit different. First of all, it's not a game. So you will often hear game and Second Life used in the same sentence. It's very rarely correct. Games have signal characteristics. They have things like artificial conflict. They have resolution. When you play a game of chess, either one person wins or it's a draw. Second Life doesn't have any of those elements. It doesn't really apply. The other thing that's really important is that most of these games, what you do is you build a big development team. They spend years creating content, that content that gets put on a disk and gets shipped to you. You as the player then consume that content. In Second Life, we don't give them any content. We give them tools. We give them the ability to create their world, to create their experience. And so everything within Second Life, and in fact all the screenshots you'll see, are all made by the users. And they're all made in real time in Second Life, which is a pretty important point. So imagine we were in Second Life together. If I was creating something that would be taking place on the server, we'd all be experiencing that creative act together. It's not like the web, right? If you go to a blog, one person posts, and then sometimes later somebody else posts, and then a flame war erupts. You know, it's a very different interaction than what we're used to in the real world. So we already talked about that. So how do we allow user creation? There are two pieces. Atomistic construction is the actual mechanics of how we build. We'll talk about that a fair amount because that gets to the heart of why we need a scripting language. The second one is making decisions to encourage user creation. Things like picking the right intellectual property regime. In our case, allowing the people who create to retain ownership of what they create. Normally when you open a piece of software, what do? You have to go through the click-through license. Well, in most games, in fact, in all games, there'll be a few sentences. They will say things like, we own everything you do in this space. And if you know anything about copyright, copyright requires the creation of something and it has to be fixed. Well, it turns out anything you do online matches that definition, right? If we weren't recording my talk, no copyright would exist in it. But because it's being recorded, it can be copyrighted. Once you move online and you're doing things like chat, it's all copyrightable. So copyright covers all of it, and most games take control of all of that. We don't. The other thing is we're not a subscription. So again, traditionally online games, you say pay $15 a month forever, and then you can play the game. Well, if you think about subscriptions, they end up being a really dumb pricing model because they're the wrong price for everyone. If you're a really casual user, paying $15 a month for something is not something you want to do. You're like, but people forward predict pricing really badly. So they'll forward predict out and be like, that's hundreds of dollars a year. Why would I want to do that? This first 5 minutes of this experience doesn't feel worth hundreds of dollars a year. Conversely, you have the people who are really passionate about this stuff. And if you let them only pay you $15 a year, you're massively underbilling them. So what we do is we have this large distributed grid. We'll talk about the technology. And how we resell our computing resources is using the proxy of virtual real estate. We sell land. So if you want more of our CPU horsepower, you need to buy more land. And so people pay us between $0 a month and 30,000 US a month. And we have a lot of people paying us on that upper end. Because folks who are paying 30,000 a year are cash flow positive, or 30,000 a month, they're cash flow positive. They're doing this as a business. That's an investment for them. So why do we do it now? The obvious things, you can't do user creation if you can't stream. You really can't stream 3D without broadband. You need consumer adoption of 3D to be able to draw it. And thank you, Bubble, for pushing out a ton of router capacity so you can do spooky action at a distance. So we launched with about 20 simulators. So each of these little dots that you can barely see is a physical white box machine sitting in a colo in San Francisco. And each one simulates about 16 acres. Anybody has a good conceptual idea of how big 16 acres is, I salute you because nobody knows how big an acre is. So it's 256 meters on a side. And where we are today is about 3,000. So that's 200 square kilometers. That's 3 times Manhattan. And over this entire space, we're doing rigid body dynamics. We're doing Navier-Stokes wind simulation. And we're running a bazillion user-created scripts. And there's somewhere between 20 and 30 terabytes of user-created data at this point. So another way to think about scale rather than physical scale is to think about it as economic scale. So in July, about 140,000 distinct people logged in and used Second Life. They bought, sold, and traded 380,000 different things in 10 million transactions. Now, 380,000 is like, well, that seems like a big number. How can you get your mind around that? So a Walmart, like a big box Walmart, has 40 or 50,000 SKUs, 40 or 50,000 distinct items in it. So this is 8 times a Walmart per month, all of it user created. The other thing that is interesting is about $10 million US is the equivalent value of what they're selling, and about 1.3 million of that was traded on open market. So people went to eBay and said, I have virtual currency, give me some US dollars for it. And we run one of the trading sites. Obviously eBay is an option, there are several others. But $1.3 million a month. So this is the pot. This is what people are competing for, the folks who want to try to make money. And as you'd expect, it's a power law with some people making a ton and some people making a lot less. So we'll kind of skim this stuff, but if you want to allow people to really create, if you want people to build, you have to make some choices around user creation. Obviously, we already talked about property rights. The amateur-to-amateur education is a really big one. When you're dealing with difficult, complicated processes, you don't want to have to educate your community about every piece of it. You want the community to self-educate. What's great about Second Life is it's a great tool for teaching users about Second Life. So what's the plus side of property rights? So this is the game Tringo. This is a game completely built within Second Life. It was built by an Australian guy who over a vacation said, I'm building a game in Second Life. So he built Tringo. It's sort of this bizarro mashup of Tetris and Bingo. And it swept Second Life to the point of people writing long, involved blog posts about how this game was ruining their virtual world. But leaving that aside for the moment. So this is Tringo on the Game Boy Advanced. Game Boy Advanced is a physical game machine. You can go down to Target and buy it. So game built in virtual world ported to the real world because the guy who wrote it retains the IP rights to it. So he sold those rights to another company to make it for the GBA. It's just been licensed again, and it's going to be a TV show in the UK because they are, the UK is all over, game shows. So here you have virtual world game, real world game, TV show, all because he retained his IP rights. If you want to really understand the value of IP rights, this is Hernando de Soto. I don't think he's ever been on the same slide with a virtual world before, but he's a developmental economist in Central America. He's very smart and will win the Nobel if Sendero Luminoso doesn't kill him first. And what he talks about is property that isn't fungible isn't actually valuable. If you can't convert property into value, there's no point in having the property.
Hey, Corey,
yeah.
You said earlier that Second Life wasn't a game.
That's right.
But you could use, obviously this fellow used,
Mm-hmm.
used it to build a game.
Visual Studio, not a game. Well, at times it feels like a game, but that's a different discussion.
Okay.
Right? So Visual Studio can be used to make games, right?
Right.
Windows, definitely not a game, right? But you can host games on it. The web, not a game. You can host games on it. So think more platform or place, not product.
Okay.
Yeah.
How would you compare this to, say, a 3D Civ environment?
A what?
A 3D Civ environment?
3D Civ environment?
Yeah.
So like Civilization?
No, not Civilization. What is it? You know that people walking around in virtual world?
So,
What's that game that was fairly popular?
so The Sims?
Yeah, The Sims.
So The Sims, which had both a single player. So the question was, how would I compare this to The Sims? The Sims was both a.
Downgrade this there, but just I don't know this.
Yeah, no, fair enough. How would we compare Second Life to The Sims? The Sims is both a single player and a multiplayer game. The important thing is it's still a game, though it did have some elements of user creation. And in fact, we'll get to a slide on that. It still had fixed requirements. You were driving your doll around, your sim, and you had to make sure your sim didn't wet itself, that it had a job, that it was happy. And we don't have any of that. In online role-playing games, there's the signal characteristic of leveling, and this came from Dungeons & Dragons. Leveling is the mechanic of you spend time to advance. If you spend time, you can get the better sword to kill the bigger monster, to get the even bigger sword to kill the even bigger monster, repeat ad nauseum. And what comes along with leveling is that you can't do certain things until you get to a certain level. Second Life, none of that. You get everything on day zero, you walk in, you have access to everything you want from the very beginning. So, the other cool thing about giving people rights is it lets them take on really large projects. This is a guy who built an entire island, so 16 acres, as sort of an ode to anime culture, to Japanese animation. And it's kind of cool because it has different areas. It has like happy, shiny rainbow anime, and it has like dystopian buildings are falling over anime, and of course giant robot anime. And what's interesting about this is while he did this, he was unemployed. So he spent 6 months, this was all he was working on. And while he did that, his whole household income was his real-world wife, which is Kasi. Her in-world name is Nephiline, who's one of the best clothing designers in Second Life. So their entire household income, including being able to move and allowing him to go build that island, was her designing and selling clothing in a virtual world. And of course, there's lots of evidence that radical decentralization works, right? Look at the web, look at eBay, blah, 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 open source, buzzword stuff, right? Or hey, Wikipedia, right? Yay, that works. So we all agree with that. However, there's some issues. Generally seems to work best in text, right? There's a vanishingly, you guys all, we all listen to podcasts because we're totally cutting edge and cool and stuff, but The number of people who create podcasts versus listen to them is still vanishingly small. Number of video, blogs is still very, very small. So most of this is still text. And what's interesting, this is one of the great hand-waving slides ever. So this axis is the number of people who actually create in a medium or in a product. And this is sort of how hard it is to make something. So like the web, depending upon how you count it, usually sits around 3 or 4% of the people who have surfed, a billion, versus the number of people who have made a website, created a blog. Blogging has actually raised this up a lot because blogging is so easy. So The Sims, here's the game that you asked about, had about a 1%. Sims 2 had about a 1% because they really built carefully to allow for user creation. Sims 1 had about a 0.2%, I think. Wikipedia is 0.02%, so the number of people who read Wikipedia versus post to it. FPS mod community, so first-person shooters are games that are designed to allow people to modify them. And there are maybe 1,000 modders out of the 50 million people who play them. So that's kind of not so good for user creation. And so you think, well, okay, what if there's economic motivation, right? If people can sell collections of Lego Star Wars dudes on eBay or their handmade jewelry, clearly that will help. And, well, no, it doesn't. In fact, eBay sits right at this 4% number in terms of the number of people who are sellers on eBay versus the number of members that eBay has. And, of course, let's not even talk about, say, Linux, where you've got millions and millions and millions and millions of people using it and, a few people who contribute to it. And so what's weird is that if you throw Second Life onto this graph, we're almost as hard as a first-person shooter mod to add to. We're talking about writing code, creating 3D models, designing clothing, building businesses, running multinationals. And in any given month, 2/3 of our residents build something from scratch. So we're not even talking about modifying existing content. So this is opening the object creation editor, opening a blank text editor, and writing code. And
So these are people who made a conscious decision they bought into this from the get-go.
This is 66% of anybody who logs in a given month will play with making something from scratch. We have not yet begun to talk about what those motivations might be, but
You notice that number, is that number constant as your user base grows?
that number has been fairly constant. However, we did not track it this way earlier, but I can't imagine it being much higher than this. Yes? If only we could get to actual scale. So the question was, now we're talking percentages. So let's talk about it on a daily basis. So we have 145,000 hours of use a day. And about 25% of the time is spent creating something in Second Life. Well, if you do the numbers and multiply this all out, that's 18 user years a day of creation. So if I had to pay them, that's a 6,500 person content creation team. So that's $650 million a year if I had to hire them. So this is sort of one way to look at scale. And this is on a daily basis, day in, day out, and this number keeps going up. And this keeps scaling. And compare this number to any open source project as well, and it still looks like a pretty big number. We'll come back to total numbers as well, but we have about 350,000 users at this point, and we're growing at 15 to 20% a month. So in terms of absolute scale. So when you give people this much freedom, there are occasionally unanticipated consequences. So these two users decided that Second Life as a place needed alien abductions to make it more real. So they built this crazy spaceship, and they built their evil aliens and alien probe devices, and they'd fly around, and this beam of light would come down, and it would suck your avatar up into their spaceship, and then they'd stand around menacingly, and then they give you a T-shirt that I was abducted by aliens and alienly probed, and all I got was this lousy T-shirt. And the brilliance of what they were doing was that they only did it every few weeks. So for a while, there'd be people posting in the forums, I was abducted by aliens. And the forums would helpfully respond with, maybe you need to get more sleep. And so, there's no way we could have a priori thought, gosh, this would be funny, that this would be a good thing to put into Second Life. But wait, because it does get worse. So originally, I talked about how we use land as a proxy for CPU resources. Originally, we had this really complicated system of sort of taxation and stipends, and made a really good story, and the economists thought it was really neat, and it didn't work at all. And the users, of course, quickly determined that it didn't work at all. So what they started doing was taking their builds and lighting them on fire. And then they'd light themselves on fire, go to the welcome area where new users are supposed to be coming into the world, and they'd stand around on fire saying, "Don't come here, it's taxed and it's horrible." So imagine, imagine you're going to a foreign country, and as you get off the plane, rather than being greeted with leis and beautiful women, you're greeted with people on fire telling you to go home. As you might imagine, this took our new user influx rate to about 0. So we changed how we did stuff. So when you hand the power to the users, you really have to buy into it. So who are these people? They're about 350,000, 15% monthly growth. And of course, what you're thinking right now is, hooray, we've found the 350,000 geekiest people in the entire world. And these are the people who are doing all this. And we're about 37% international at this point, just to give that. Except that's not really the case. We are, by hours of use, 50-50 male-female in terms of real-world gender. This is very atypical for tech early adoption, and certainly very atypical for a game or entertainment type experience. Now, we do have more men using Second Life than women. The women just use it more. So if you log in, half the people you bump into are actually women. The other thing, give me just a sec.
Do you have a breakdown on who does more?
Yes, actually. Any way you measure top 10 lists, most money, most construction, most friends, most land owned, any way you measure it, the top 10 lists are dominated by women. And some sociologists will eventually study that, and it will be an interesting answer. The other thing is, the older you are, the more you use Second Life. Again, very atypical for tech. Also, at any given age, if you're a woman, you use it more than a man. And the median age is about 33, 32. It's been bouncing around a little bit. And we don't know why this is.
How do you know your data is real?
We don't.
How do you know that someone's
We don't.
32 and they're really 16?
We don't. Because it's the internet. Thus, it could be, in fact, 350,000 dogs using Second Life, right? And so, now, what we do know is, so the residents have done community conventions. They've done a lot of meetups. In fact, one of the other atypical behaviors, traditionally online groups have tended to put up very firm walls between their virtual identities and their real world identities. And what we've seen in Second Life is people completely ignoring that and saying, no, 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 no. Second Life's an extension of my real world social network, and the real world is an extension of my Second Life social network. So we have a lot of survey data on actually meeting hundreds and hundreds and hundreds of our residents. And in meeting them, the people we have met have roughly matched the demographics we expect. So there are a lot of studies going on right now to try to get better data, but this is a classic problem in doing any studies online, is your data is always a little bit because until you meet them, you don't know. Yeah?
Sorry to ask a common question, but Linden describes a lot of garbage in the multiverse also. Do you filter that, or does the community filter it?
So the question was, in the metaverse, which is the fictional analog of this created by Neil Stephenson in the book Snow Crash, there's a lot of junk lying around. So, the web also suffers from a lot of junk and a lot of link rot. What we've found is because people have to pay us for computing resources if they want permanence, they clean up their stuff. So while there are very low marginal costs of reproduction, it is not zero. Because after all, we still have to host their data, we still have to serve their data, we still have to run their scripts. So, traditionally in creating interactive experiences, there are these hard problems like making 3D objects, making good-looking people, and writing scripts. Hundreds of millions of all of these made by this sort of random cross-section of the US and the world. And this is really interesting because we wouldn't have expected this. We would have thought we would have had a much smaller core group of creators. The other thing that's cool from my end is we have things like this. This was, one of our users said, gosh, Second Life needs a notary because there's all this business going on. So he wrote a notary in the scripting language to do signing of text documents. So we hired him. And in fact, we'll talk about some of the problems he ran into. So people make lots of games in Second Life. I don't want to spend too much time on this, but again, it's a platform, it's a place. People play in the real world, people play in Second Life. We already talked about Tringo. Sailing is actually one of the more common activities because we do really pretty water, and we don't handle super fast moving vehicles very well. So sailboats were a good balance point. So the Second Life Yacht Club just celebrated their 1-year anniversary. We also have a lot of stuff beyond games. So this was FEMA working with UC Davis to do medical prepositioning experiments, because when you have a physically modeled space with avatars, you can do things like, well, if we're an avatar is your representation in the world. So you'll see this more when we do the demo, but like this guy standing here is the representation of a real world person using Second Life.
That's an avatar.
That's an avatar. And so what's nice about an avatar is, let's say you're trying to figure out what order you unload your medical supplies. You need to make decisions like, can we then get to them in the right order? Being able to actually walk people through the warehouse is a very useful way of doing that. UC Davis has also done experiments with doing training for in hospitals for code blue teams, for the people who respond to cardiac arrest. Again, you have 5 people on the team. They have to move to certain places, and you can't shut down hospitals to do the training. And so being able to do very quick mock-ups and say, well, this room looks like this, let's see how we move the people in, has proven to be very valuable. They also did things, this again was Davis. This was the Virtual Hallucination Project. If I had millions of dollars, I could maybe make this room simulate schizophrenia for you, but probably not. And in a virtual world, it took a month. And what they did is they did patient interviews and then built all the hallucinations, both audio and visual, into Second Life. So as you went through this hospital in Second Life, you experienced the same thing the patients went through. This is similarly, it turns out we have a bunch of stroke survivors using Second Life. Because post-stroke, you have a limited period of cognitive recovery where if you don't use your brain, you're going to lose function. And the problem is, if you're mobility impaired, you don't get to go out and actually interact with people and do all the things you do to keep your brain active. Well, Second Life has proven to be a really good place to exercise your brain, both mechanically building things, interacting, doing social things, running businesses. So this entire county fair, and this is actually just a piece of a huge place, was actually constructed by a group of stroke survivors. And in fact, the woman who ran it had her second stroke about 2 weeks before the grand opening and just got out of the hospital in time to do it. So again, think about this. These are people who may be mobility impaired, stuck at home, but they're able to still collaborate and build on a very large scale. Ancha, so this is probably our largest moneymaker. She does real estate. She made somewhere around 150,000 US last year. So she was on the cover of Business Week while her avatar was on the cover of Business Week. So amateur to amateur, we've talked about how people learn about things is largely through interacting with other residents. So the key is sort of the on-demand learning aspect of it. I need something, help me. Well, there's usually somebody within shouting distance who can. And it's proven to be good enough that last semester, these are the 17 universities who taught classes in Second Life. You can ask me more about that later. And the cool thing is, if you're going to teach, how much more fun is it if you can actually build a space? So this is the International Spaceflight Museum that was built by a bunch of ex-NASA and ESA engineers, well, actually ex and current. And they've been building real-size mock-ups, and then way up in the air, there's a model of the solar system that you can travel through. It's really kind of fun. And of course, what we do run into here is this whole play-work dichotomy, especially in the US, right? Thank you, Lutherans, mostly, for this one. If you're having fun, you can't possibly be working, and vice versa. And so it's just interesting that, this is considered good, and this is play. But of course, this guy was homeless, living on a friend's couch, started doing live music shows in Second Life, put out a tip jar and said, I'm living on a friend's couch, trying to raise money to get into an apartment. He was able to do that. But this is play and therefore somehow inferior to serving a flurry or whatever the hell that is. Anyway, so we have people building classrooms, lots of education stuff to go along with all of the sort of fun stuff. Let me just pop ahead a little bit. One of the key elements, so this is the Beyond Broadcast Conference at Harvard. They were doing a discussion of sort of the future of public media. Here is the web stream being projected inside Second Life. Here's a Dalek who's only attending virtually. But of course, this is on a laptop with a guy sitting at the actual conference. Right? And so, and the key thing is the Dalek could ask questions to the speaker.
What's a Dalek?
It's a Doctor Who creature, really high-class special effects sci-fi robot. Evil robot, yeah. There we go. Thank you. And so, but the key thing here is here you have people who aren't actually there geographically who can still interact with the conference. They can see what's going on. They can ask questions of the presenter, and they can be part of it without actually being there, which is pretty cool. So how does all this stuff get built? Well, first of all, we build physically using geometric primitives. So rather than being a polygonal modeler like, say, 3D Studio Max, where you build out of individual polys and extrude things like that, we're technically a solid body modeler. So you build out of sort of things and stretch and pull and intersect them. So this really not so good UFO that I threw together, you can see it kind of breaks into these pieces. And again, all of this editing takes place on the server side, so none of it's client side. So if I'm sitting there playing with this stuff, other people around can be interacting with it. And let me just skip that. So it would be really cool someday when everything we wanted to do in virtual worlds we could do physically. Right? You know, the skydiver jumping off the Eiffel Tower here, you know, we're actually doing finite element analysis and Navier-Stokes, and that's how we're determining how the parachute works. And you know, if you want to put butterfly wings to make your avatar fly better, we're actually again doing the fluid mechanics to do that. Wouldn't that be great? And of course, we are nowhere near being able to do that. Now we have somewhere on the order of 3 teraflops of processing power going just toward physics simulation. And that's almost enough to do rigid body dynamics. So, you know, how do we do the rest? And I picked flying as the example only because it's one of the more evocative things, and everybody who comes into Second Life decides to play with flying. How are we going to do all this if we can't actually simulate it? Yes?
Just a quick question. Don't spend a lot of time on it, but just curious about what hardware you do for calculations.
So we're running on dual core Opterons for power reasons.
Do you have a big array of them?
Yeah, so there are 1,500 1U boxes sitting in a colo in San Francisco. And that's continuing to grow as our customer base expands. So that's what powers the back end of all this.
So another question is, like, I guess almost all the people in Second Life now are the early adopter crowd, right? Like, you know, they're in. Now, like, what almost always happens eventually is that you start getting consultants for people doing things that normal people can't do. Have you started to see that already?
Yeah, so the question was, you know, you have the people actually building the stuff in world. What about when some outsider comes in and says, hey, I want something? And yeah, there are about 6 companies now that exist exclusively for doing engineering services for Second Life. And that's ranged from doing the BBC One Radio Weekend in Second Life. American Apparel just built a store in Second Life. Major League Baseball did the Home Run Derby. They did a simultaneous event in Second Life. We're starting to see major outside organizations come in and start playing. In fact, it's a lot like the web was in '94. So when I connect to different groups, both technical and otherwise, every company now has like the one guy who's discovered virtual worlds or Second Life and is saying, hey, we need to do something with this. And it sounds a lot like that one guy in '94 saying, we need to own our domain. And the whole company's going, no, that's stupid. Yeah.
Is Google or Microsoft already taken?
In here?
Yeah.
Nope. Investment. Right. So if we can't do it with physics, you have to do it with code. Right? You have to do it with script. You have to use stage magic to fake all the things you can't physically simulate. So when we set out to build the scripting language, we had some absolute requirements. Because we knew we'd have many, many, many of these scripts running. And we wanted to make sure that, okay, here are the rules. Nobody's script can take down the machine, either by memory or CPU horsepower. Obviously, you don't want them pwning the machine. That would be bad. And and we're talking on the order of thousands and thousands of user scripts per machine. We'll get to the specific numbers. And the important thing is you have to assume hostile code. Right? Here we are saying, please bring your scripting code to us. Run it on our machines. So you have to assume that they're doing everything possible to destroy the machines they're running on. And the other thing is, so at any time in Second Life, I can have some object. Yeah, we have to have the requisite snakes on a plane joke because somebody had referenced that last night. So I'm walking around. I have a scripted dog following me in Second Life. Well, at any time, I can take that dog, close it up, and put it in my pocket. At which point, we need to suspend all the scripts running on it in a way that it can just be reinstantiated whenever we want. More importantly, as that dog wanders through the world, 3,000 CPUs out there, it's moving from CPU to CPU. CPUs in Second Life are mapped one-to-one to geography. So as you move around in the world, you are constantly being transferred machine to machine, CPU to CPU. Again, you need to be able to suspend those scripts at any time to do that. And of course, it would be nice if it played nicely with physics. Here we have a physical world, so it'd be good to be able to apply forces. And obviously, since nobody ever figures out all the library stuff you need initially, you want to make sure it's relatively easy to add more in. Yes? Uh-huh.
I have a little website.
Yep.
That I started that is centered around a community for people who need fitness.
Uh-huh.
Right? And one of the services I wanted to provide was I wanted to have personal trainers be able to sign up and manage their clients.
Yes.
As a separate service, I was looking for a way that you could provide information about like the avatars, properly doing exercise.
That's right.
Things of this nature.
I don't know that anybody has done. So the question was, if you've got, say, a fitness website, could you use this as a way to pass knowledge, both in terms of showing proper biomechanics, doing things like being able to work on the community aspect of it, giving people support, because after all, fitness is all about go do it today, don't slip off today, and those sorts of things. I don't know that anybody has tried that professionally yet, but you can create animations. You can make your avatar do whatever animations you want. And there have been people doing fitness things in Second Life. I don't know whether they've connected them to an existing community yet.
Would I be able to somehow, connect one of my users to that without having to get them out of my portal? Is there a way
So there will, real soon now, be federated authentication for doing signups. So that'll allow you to sign up. Now, Second Life doesn't run in a web page. It's a standalone executable. And so you actually have to get them to go download it, but you will be able to get them to go download it from inside your site. We also have what's called a slurl, which is a URL that maps a different protocol that our executable recognizes. So if you've installed us, you can click on hyperlinks, which will launch Second Life and take you to a specific location inside Second Life. The scripting language also speaks outbound using HTTP requests, so people are already starting to flood Delicious and other things with all sorts of metadata from inside. So I'm going to keep going if you don't mind, because I don't want to run into time. Yeah, that's what I'm trying to get to. But
Corey, you said that you sell real estate.
Yes.
To your business model. So a community is assigned a particular piece of hardware. Is that real estate mapped to a piece of?
It's not. It's mapped to a class of machines. Obviously, this will come as a shock, but occasionally we crash and do things like that, bad things. So you need to be moved around, but you get a class of machine if you buy land from us. So like right now, almost all of our machines are the exact same dual core, dual Opterons. So anyway, so we rolled our own scripting language. This was 2001 was when the scripting language got written, looking at a few things, mostly because it got written in a week, like all scripting languages. It was determined by me one afternoon that I knew more about writing my own than, say, beating Java into submission, especially because things like suspension and running massive numbers of parallel threads. And so we rolled our own. And people do all kinds of things. We have people who have built skateboards that use the scripting language to behave like a skateboard and trigger animations and properly react to the terrain. And so what did we make? So LSL2, because technically it's the second Linden scripting language. The first one got written, anyway, leaving that aside. So it looks a lot like C, only worse. Doesn't have structs. It has heterogeneous lists, sort of. It also has a lot of basic types that map well onto physical simulation, things like vectors, quaternions. So we have a ton of people using quaternions. Anybody in this room even know what a quaternion is? Wow, that's a pretty... Quaternion is just a representation for rotation. It's technically a point on a four-sphere, on a hypersphere, but it's a four-vector that represents rotation in a way that's really nice. So we don't call it a quaternion, we call it a rotation. But anyway, so did it work? Well, right now at any given point, we have about 5 million user-generated processes running on the Second Life grid. So these are scripts. It's about 5 million. Doing everything from this blog HUD. What this does is you put this on your avatar, and it allows you to blog directly from in Second Life. So as you're walking around, I see something cool, and it'll pop out, and it'll use HTTP request to pound a blog, and doop-de-doo. Then you have blogs, and it'll insert slurls. This was the American Cancer Society that did Relay for Life inside Second Life, and they ran How far did they run? 6 million meters. They raised 40,000 US dollars in the virtual one. So in that sense, clearly there's been a certain amount of success. But who uses it? Well, and I apologize, this data is actually pretty out of date. This was January, because it's a very messy query to get at. But in like a 7-day period, I was seeing about 15% of the people logging in, opening a text editor and writing a script. So again, going back to our demographics of completely sort of random US users, or international at this point, about 15% of them per week will try to write a script using our oh so special text editor with colors and everything. And remember, this is writing a C-like language, only harder. This isn't, visual mumble. This is a difficult language. And so about 12,000 distinct scripts a week getting written, about 3 million lines of code a week being written by our residents. So in that sense, I'd say it's probably been a pretty much a success. But like I said, it was written in a week, so it has some quirks. This is a technical term, that it runs ass slow. So we're only running about 150 million instructions per second over the entire grid. Now, a big part of this is the fact that, well, it's a really, really, really bad bytecode interpreter. Again, it was written pretty quickly. The other thing is, we do have resolution for suspension down in the 100 microsecond or less range. So we have very, very fine-grained control, probably more fine-grained than we needed. And so it ends up being that, of course, your timer overhead ends up being a big part of why it runs slow. The syntax on a good day I would describe as inconsistent. On a not good day I would describe as completely random. And of course, there's no real-world support. Nobody's using LSL to do real-world applications. Now, there is real-world support in the sense of there's a fantastic script wiki. If you search LSL wiki on Google, you will find the script wiki. If you search for any of our library functions in Google, the first hit you will get will be the script wiki. So in that sense, the users have done a really good job of documenting it, but they've been documenting something that's a little bit messy. And so with that, I think we will switch over to Jim and let him talk a little bit about how we then came to look at first CLI and then mono. You can wait. Why don't you wait on that? Yeah, we'll switch machines
Later on, yeah.
Okay. Why can't we run second light from here? Because the
Firewall issues, yeah.
ports are blocked.
Can everyone hear me? Yes? No? Is that better? Better?
A little bit better. It's easier to have someone else pin you up than to try to do it yourself.
Hello. Is that better? Right. Okay. So we've got this wonderful scripting engine. People are writing scripts. They're doing loads of cool stuff with it. It runs really slowly. It's not very consistent. Can we do anything better? So we started looking at the CLI, and actually I realized I've missed the kind of first thing we got to. It's a common language runtime. So we've got a language, if we have a common language runtime, we can run our can easily compile our language down to a common language runtime, run it on that. We can get a high performance JIT. We can also run other mainstream languages. So if people don't want to go through the torture of learning this nearly C, but with slightly crazy bits, they can maybe use C# or VB or whatever else they want to use. There's also a rich pile of libraries. So we've got maybe a 300 script library calls that you can make. A lot of them are Second Life specific, like to do the physics and to do animations and stuff like that. But lots of them could be more, could be general. Like if you want to use stacks, if you want to use collections, if you want to do networking stuff, it would be cool if we could have just a big pile of libraries that are really nice and people are used to using that they could use. And also, it's got verified bytecode, so that's perfect. We can make an untrusted code stamp it. We only run verified code in it. Nothing bad can happen. Everything's good. So the hope with this stuff was also that we could allow larger and more complex applications. So given that we've got this C syntax, obviously you get the problems of writing big C programs. But before you get to those boundaries, the fact that we ship each script around in a 16K block, which is its stack, its heap, and its text, means that you can't make very big applications. And in fact, the way people make big applications in Second Life at the moment is they create loads and loads and loads of 16K scripts, and then they go through lots of horrible torture sending messages between each other. And so people can and do build big applications in LSL. It's just really, really horrible. So we wanted to, once we've got a JIT, once we've got a more high-performance scripting engine, hopefully people can can do more heavy lifting tasks like writing proper AI, doing A-life experiments, which people do now, but in a fairly limited way, doing things like procedural generation, things like maze generators and environment generators. People have done in LSL2, but it's fairly painful to watch it happen. So that was kind of the reasons we came to the CLI. So why do we come to Mono? Well, all our servers run on Debian. We've not got 3,000. We've got maybe 3,000 CPUs, and we're adding about 300 CPUs a month, and we update every week. So we want to be able to go splat, 3,000 new processes all running our updated code. So this is our master plan, probably about a year ago now. So over here we've got the viewer, which actually contains the LSL2 editor and the compiler at the moment. Then that sends LSL bytecode over to the simulator. We've got the CLI verifier here, and then we've got the simulator running the scripts on Mono. And also, because we're shipping bytecode between the viewer and the simulator, we can have people using Emacs or Visual Studio or Xcode or whatever to do C# or VB development, and then we can just, everything's a CLI assembly. We don't care what language you're doing it in. It'll all be great. So that's the plan. Problem 1. Concurrency and mobility. So some simulators, some regions in Second Life run up to about 2,000 scripts at the moment. If we're going to have a more high-performance scripting engine, it would be nice if they could run 10,000 scripts in a region. So that would be pretty much every single box in a region in Second Life has a script running on it, so it can be interactive. So that's kind of like the high-end limit of our interactivity. If you can interact with everything, then that's great. So long-running methods can be legitimate. There are scripts in Second Life which are basically just one big infinite loop, and they spin around an infinite loop, and they might go to sleep for 5 seconds, change the color of the object they're in, then go to sleep again. So you get kind of like flashing neon signs just implemented as infinite loops. So it may not be the best way of doing it. There are other ways, like you can actually just schedule a timer that will call you an event handler back every time the timer goes off, and then you change the color of the object you're in. But people can and do write scripts which just do an infinite loop doing this stuff and going to sleep. So people need to be able to effectively run methods which last forever, but at the same time we need to avoid denial of service. So we can't use the thread pool to do this, because we schedule an operation, it goes into an infinite loop, and it sits there forever and never comes back. So we either have to abort it, which is bad because this could be a legitimate script, or the machine's pwned.
So you're doing your own multitasking in your scripting language?
Right. So yeah, at the moment we've got a scheduler inside the simulator, and what it does is it interprets a few bytecodes. When the script runs out of time, we schedule a new script, and it turns out that we need to do something kind of similar with Mono. So Mono by default uses operating system threads. So okay, well brilliant. We'll map a script onto an operating system thread. Well, it turns out that after about 60 odd concurrent threads on Windows, or about even 1,000 on MPTL, if I've got that round the right way, on Linux, things start coughing and wheezing. And even if we could run each script as its own independent operating system thread, we still need to be able to migrate and persist these running threads. So imagine you've got the script which infinitely loops changing the color of an object, you attach it to a rocket, and then you fire it across the Second Life world. Well, every time it goes 256 meters, it switches to a different simulator. So we need to migrate that process to a different simulator, even though it's running an infinite loop. So this is horrible. We can't do it with an operating system thread. So we need to be able to migrate and persist the stacks. So what do? Hack 1, microthreading. So although Mono uses operating system threads, CLI uses operating system threads, and we can't migrate them, you can induce the stack state. This is what the bytecode verifier does. So you can step through your opcodes, you can induce the stack at the next opcode, all the way down through the methods. So at any point in any opcode in any method in a CLI method, you can work out the types that are on the stack. you can also rewrite bytecode. So reflection emit does half of it in that you can like build some bytecode and spit it out. There are things like Rail and Cecil which do the other half, which is reading an assembly, creating an object-oriented representation of it in memory using the reflection stuff, and then so you can read in an assembly, walk through all the methods, look at all the bytecodes, and basically whenever you see a backwards jump or a function call, you can go, right, do I need to yield? If so, then I can pop all the types off the stack. I know what the types are. I can copy them into an object on the heap. I can stick them in the heap, and now I've got a proper object which I can serialize along with the heap objects, and I can ship it somewhere else with the assembly. So that's what we do. We inject microthreading into CLI assemblies so that we can run shed loads of them, and we can pause a running method at any point so that we can ship it somewhere else. And this is a similar approach to a number of mobile agent technologies written in Java. So Java GoX and Breaks do similar things. And I've just found out that someone at Microsoft also does something similar in CLI, so I'll be talking to them later on. So once we've effectively copied the CLI stack to a heap object, then we can serialize that stack along with the heap objects, and we can transfer the assemblies somewhere else. So we can run lots and lots of scripts. We can run our 10,000 scripts if we need to, and we can migrate them somewhere else. Yep.
How do you reactivate the stack? Okay, you save the information from the stack. Now how do you store it?
Okay. Dun, dun, dun. Right. So here we have the Fibonacci method up here. Here is the CIL bytecode, and I'm quite pleased to stick this on here because no one actually got some bytecode out, got some CIL assembly out. So it's LangNet conference. I'm quite happy to do that. So that's what happens when you compile the Fibonacci method. Then you inject microthreading into it. So you end up with this. You come in at the top of the method. You go, am I restoring? Which answers your question, right? At the start of each method, you go, am I restoring? And that makes a static call which goes, are there a bunch of stack frames on the microthreading stack which need to be unwound? If I am restoring, then I pop the stack frame off the heap. I cast it to the stack frame for this method, and then I go unload all the. I sort of basically pull all the variables out of that object and push them onto the CLI stack. Then I have a special variable in that stack frame, which is the program counter, effectively. I jump into a switch. I've got 3 locations in this method that I can resume from. And so then I'm jumping kind of past this stuff into the other parts of the method where I left off last time. So if I'm restoring to a function call that I made, I then do the same thing again. I peek in the microthreading stack again, and if there's and there should be another stack frame because I'm restoring to a call site. So then I'll call resume on that stack frame, and calling resume on that stack frame will then call another method which will do the same thing. So when I'm restoring, I've got this big pile of stack frames on my microthreading stack, and I kind of go through each one, restoring the CIL method call state each time. And then once I've run out stack frames, then I'm in the kind of the bottom of the call stack, and I can start executing again. So if I'm not restoring, is a save due, and that's currently making a timer call, although we're going to change that because that's horrible. If a save's due, then I basically just jump straight to the end of the method, and I build one of these stack frames, copy all the variables from the CIL stack into the stack frame that I'm going to keep on the heap, and I push it on this microthreading stack again. Yep.
This is cool, but I mean, this may be a dumb question. How are you actually doing this? How are you modifying the bytecode here?
Yeah. So the question.
Just a little bit technically of how you're modifying it.
Yeah. So the question was, how are we modifying it? Well, we're actually using Rail, which is a library which allows you to do this round tripping of assemblies. And basically, you point it at an existing CLI assembly, and it'll read the assembly. It'll use reflection to figure out it. It'll actually read all the bytecodes. It'll create an object-oriented representation of the entire assembly. So it'll have a collection of methods, and the collection of methods will have a collection of opcodes in it, and you can step through the opcode collection going, what's the opcode here, what's the opcode here, what's the opcode here. Now, you have to in order to make this stuff work, you need to know what's on the stack at the point where you want to suspend the method. And so to do that, you do the same thing that the bytecode verifier does, which is it goes through each opcode and goes, right, this opcode pushes an int on the stack, so now I've got an int on the stack. The next opcode, pops an int and pushes something else, so I've now got something else on the stack. So then you can get for each opcode the types that will be on the stack at that point. So then when you want to save stuff, you can go, right, what's the superset of all the things that I'm going to need to save for all the different restore points that I've found in this method, all the backwards jumps and all the call size. And so then you generate a class, kind of like using generics, which will store all that stuff in it. So then when you go through when you're actually running the code, when you get to one of the places you may have to yield, you then go, okay, so I need to yield, so I can pop stuff off the stack, I can build one of my stack frame objects, copy all the values that are on the stack into that stack frame object, and then return, because I've saved the stack somewhere else. So then I've got a collection of managed objects, which is a list of, or an array of these stack frames, and they're managed objects, and I can then ship them somewhere else. So that's basically how we do it. So where have we got to? Do we need to save? If so, jump to the end, pop all the stuff that I know is on the stack, because I've worked out where the stack state is, copy it into a heap object, push that heap object onto my microthreading stack, and then just return. And so if I return to another method that's calling me, this is Fibonacci, so there's going to be lots of recursion going on here, then each time I return, I come back to this. After each call site, I go, am I saving? And that goes, is there a stack frame on the microthreading stack? And if there is a stack frame on the microthreading stack, then I'll do the same thing myself. I'll save my state, I'll return. My caller will go, are we saving the stack? If so, I'll do the same thing. So you basically unwind through the whole thing, and you end up with this bunch of managed objects. So now we can run lots and lots and lots and lots of scripts. We can run 2,000 scripts, 10,000 scripts, and we can pause them at any point, and we can ship them somewhere else. So this is good. Yep.
So you ship the entire heap there. What about the references to objects for the heap? You have to pick up the entire heap.
Right. So the way it works is that we end up with a managed object which represents our script. That may reference a bunch of other objects on the heap, like lists and collections and so on. When we store the stack, we create the heap objects representing the stack, and then our script object also references the heap objects that reference the stack. So then you can just go, right, I've got a reference to the root script object, serialize it, by reachability, I can then get a blob of serialized data, which is my script, all the heap objects it references, its entire stack, and then I can move it somewhere else.
So it's your requirement that all objects in all programs must be serializable?
Yeah, if you want to ship them somewhere else, yes. Right. So, problem number 2, unloading. So the next problem with the CLI is that we want to have a long-running process that runs for weeks at a time, and people are constantly creating scripts, loading them into memory, and then going, that was rubbish. I want to do a new one. I don't need it anymore. I'm going to delete it. So one of the problems with the CLI compared to the JVM, which other people have, like the Java GoX and Breaks people used, is that it won't automatically unload your code for you. So if you end up loading thousands and thousands of scripts into memory and decide you don't need them, then you're kind of pretty stuck. You can't just say, right, I don't need that assembly anymore, unload it. In some of our sandboxes, sandpits in England, so we have these areas where people can just experiment and build stuff. And in some of those areas, people generate 8,000 scripts a day. So if they all end up being rubbish, which they do because after 6 hours we wipe the sandpit, then we end up with 128 megs of rubbish code per day in a simulator. So after a week, we've got lots and lots of wasted memory. And we can't just unload the assemblies that we want to do, and it won't automatically do it. So Java will just go, no, you're not using this type anymore, let's unload it. At least that's the plan. So how do we do it? Well, we can do app domain scavenging, because the cool thing is now that we can move a running script from one process to another. That also means we can move a running script from one app domain to another. So the cool thing about this is that although you can unload app domains in CLI, if you've got 2,000 to 10,000 running scripts, you don't want 2,000 to 10,000 app domains, because you're going to end up with like massive memory overhead, massive overhead per app domain. So what you really want is n domains. So you want, let's have 10 or 20 or 30 or whatever. You want to decouple the number of scripts from the number of app domains. So what we do is we have n domains. So we'll, when our process starts, we'll create 10 or 20 or 30 application domains, and we'll load assemblies into all of those application domains just on a round robin. So the first one goes in the first, all the way around. So we also, when a script stops running, we track which domain it was in, and so therefore we work out how many junk scripts or how many junk assemblies we end up in each application domain. So once the number of junk assemblies reaches some magic number, we go, this domain's got loads of junk in it, we should probably get rid of it. So we migrate all the running scripts that still exist in that app domain to a new one. So we basically serialize the script, shift it to another app domain, and then all we've got in that app domain is a load of assemblies that we don't need. So then we can unload the app domain, create a new one and load it in again. So we always end up with this pool of application domains, and they steadily fill up with junk, but when they're full of junk, we migrate the stuff we want to keep, we scavenge it, like a scavenger garbage collector, then we unload the application domain again. So now we can have, in the CLI, a long-running process that just keeps loading and unloading code, and it doesn't have to have a bazillion app domains, it just has to have a pool of them, and we can tweak the numbers of application domains we have and the amount of crap that we're allowed to build up in each application domain so that we can tune the system. So there we go. There's a picture of it. So we've got 3 application domains. The white dots are the running scripts. The blue dots are the unused assemblies. So this app domain over here has got a load of unused assemblies in it. So that becomes our unload domain. And so over the next series of frames, what happens is we move the running scripts that are in that unload domain to the kind of still usable load domains. So we migrate them here, and they just turn up here in the same way that new scripts that are being created at the same time turn up. Once all those running scripts are gone, this application domain only contains unused assemblies and we can unload it. So, problem 3, other resource accounting. So we need to, as well as the CPU, as well as limiting scripts so that they can't do a denial of service on the server by hogging the entire CPU, we also need to avoid other denial of service attacks. So we actually have what could be a pretty useful zombie network just in our simulators. So like if you ran a script on every single box in Second Life, every one of our servers, on each of our 3,000 regions or whatever, if they're all making HTTP calls or sending emails to somebody, you can actually make someone's day pretty horrible just by writing scripts in Second Life that run on all of our machines, constantly hammering someone. So we need to limit things like HTTP calls, emails. We need to limit self-replication. So one of the things scripts can do is they can create a new object and they can transfer themselves, a copy of themselves into that new object. So you can end up with self-replicating objects. And this is good for things like artificial life experiments where kind of fish swim around and meet up and get, fall in love and all the birds and the bees happen and a new fish turns up. And this is cool because you can do A-life experiments. But it's really bad when somebody goes, I can just write a script which just fills the entire Second Life with random spheres covered in goatsy images. That would be bad. So we need to limit that kind of stuff. Now it turns out that all these things like HTTP calls, emails and self-replication are pretty easy to limit because all these things involve making library calls. So we just track the library calls that the script is making. We say, how many have you made in the last minute, hour, week, whatever. And if you've made too many, we just slap you and stop you running. The trickier one is memory. So in the current system, as I said, each script is like a 16K block, which is its stack and its heap and its text. And so we can just ship them around really easily. And so that's a really good way of limiting the memory because, if your stack grows from one end and your heap grows from the other end and they meet in the middle, you've run out of memory, you need to reset your script. So you can't use more than 16K of memory in the current system. But that's trickier to do in the CLI, which just kind of goes, you want a new object? Yeah, fine, whatever, we don't care. So, hack number 3, subvert the profiler. So we embed Mono in the Second Life simulator, which means that we have access to APIs like the Mono profiler and all that goodness. So rather than using this to work out how much memory each script is using, we're actually using it to limit the amount of memory that each script's running. So on object creation, we add the size of the newed up CLI object to the size of the currently running script. And on the first version, what we did is is whenever a GC happens, we go through the list of objects that have been GC'd. We go, we have a mapping that maps that object to a script, and we go, okay, so this 4-byte thing has been garbage collected, so we'll kind of do a map lookup, and we'll find the script, and we'll go, your memory size has gone down by 4 bytes, so you can now allocate some more objects. So it turns out that's really horrible, and you get GC pauses anyway, but when you start doing this kind of stuff, you kind of iterate through piles and piles of objects, and for each one you do a map lookup, and then it's just horrible. So, and also the other thing is that you end up with, for lots of scripts which never ever ever get close to the limits of memory, you're kind of like carefully making sure that you keep track of exactly how much memory it's used. Even when it doesn't really matter. I mean, this thing's only ever using 16 bytes, but every time it allocates a thing, you're adding to it, and then when the GC happens, you're going, oh, you're down to 12 bytes again, and then you're back up to 16 bytes, and it's just, you don't need to do it. So what we do now is that we still have the hook on object creation, so that you start off from how big is the assembly? Okay, that's how much memory your script's used. Every time you new up an object, we add to the amount of memory that your script's currently using. When you hit 16 kilobytes, or whatever magic number we decide is the maximum size that your script can be, we then just go, okay, so you said, you've allocated 16 kilobytes of memory, but you may actually be using far less. So we just do the serialization again. We go, let's serialize the script, find all the things that are actually reachable. How big is that serialized representation of the object? We'll use that as a kind of close approximation of the amount of memory that you're actually using. So, you might start off from 2K, which is your assembly size. You'll allocate objects up to 16K. We'll serialize you and find out that you're actually using 8K, so we'll drop you back to 8K again, and then you'll start allocating from that point. And it's kind of not perfect, but it does the trick. And the other thing that's pretty horrible about this is that you're creating a serialized representation of a script, and then you're just throwing it away. So you're copying all this memory and putting it in a serialized format, and then you're just taking the size of it and throwing it away. So we can do better than that, but that's how we do it at the moment. So at the moment, we have a collection of hacks, and it mostly works, which hopefully I'll show you in a minute. Now the cool stuff is that even with all this microthreading injection and all the kind of crazy stuff that we do, we still go 50 to 150 times faster than our current bytecode interpreter, and that's thanks to Miguel and his excellent JIT, and yay, mono, it's really fast. And also, we use less than 50% of our current memory. So because currently we have these like 16K blocks, even if your script has a single event handler and never allocates any memory, it ends up being 16K. So while these 16K blocks are easy to ship around, a lot of the time they're really inefficient, and lots of that 16K is doing nothing. So by actually only having the size of the assembly plus the dynamic allocation of both heap objects and the stack, because we only allocate memory to store your stack when you're actually using it. So if you never actually make a nested core, you only ever end up with one stack frame on the microthreading stack, which is some tiny amount of memory. So we end up using a lot less memory. And actually, it's even better than this now, I've found out, because whereas if you create 10 objects in Second Life that run the same script at the moment, you end up with these 10 16K blocks. With Mono, if you create 10 objects that use the same assembly, you're only loading the assembly into memory once. So, and actually that turns out to be quite a good payoff, because if you've got these A-Life simulations, you end up with like 100 fish in the same region. All the 100 fish are running the same code. In the old days, they'd each have their own copy of the code. Now they all share a copy. So you actually save lots and lots of memory, which is good. And the stuff we're working on at the moment is the application domain stuff, and we're not quite there yet. We've still got some memory leaks, but we've done this cycling through. We've had a test running that just sits there creating new scripts, which commit suicide after a minute. And so we're creating lots of these junk assemblies that we need to unload. And we've had a test running now for about a week, still running. So the last time I checked it had unloaded 30,000 application domains over 48 hours. So that seems quite happy, but there are some memory leaks that we need to fix.
You did say you limit their memory to what, 16K? Do you limit the number of scripts that a user can allow to use?
No, so we need to sort that out. So at the moment we have quotas for the number of primitives you can have on a certain area. So you can have one of these 16-acre regions has something like 14,000 boxes or spheres or cubes or whatever, cylinders. One of the things we need to do is the same thing for everything else. So we need to have quotas of scripts, quotas of memory, stuff like that. Yep.
One thing that we didn't see in the IL code
Yep.
is when do you check on what CPU you're supposed to be?
What's that?
When do you check on what CPU you're supposed to be? Like on the function here,
Yeah.
you have to inject code subject to testing what X and Y coordinate am I am now, and should I be shipping my execution off to another CPU?
Right. Okay. So that's so the question was how does the script work out when it needs to be shipped off somewhere else?
Yeah.
And actually the way we've done it at the moment is we've just made all the mono scripts look very much like the LSL2 scripts, and so there's actually when it goes, do I need to stop running there? Then the result of that test is, have you run out of time? Do you need to go somewhere else? Are you being stored to someone's inventory? If the answer to that is yes, then all the script needs to do is just pack itself up into a little serialized form, and then the Second Life simulator itself could go, okay, now take that serialized version of that script and either ship it to a different simulator or store it in the asset server so that we can, someone's put it in their pocket and they've just wandered off somewhere else, and then when they get it out, they'll create it again, and it'll pull the serialized form, recreate the script, and start it running again.
Okay, so there's two hidden variables, and you guys just inject the X and Y coordinates?
No. It's when it calls out, it's calling out from the injected opcodes, and it's then checking a whole bunch of things that are connecting off, and it's talking to the physics engine, it's talking to our event handlers in the main code. CLI doesn't even know about it. It just knows, it needs to know, hey, I'm about to jump back, or I'm about to do a function call, check first. Yeah, so there's a whole load of kind of script scheduling that happens in C++ that works the same way for LSL2 scripts and monoscripts. All the monoscript needs to do is we need to be able to say to the monoscript, start running, and it goes, and then every now and again it needs to go, do I need to stop, 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 and when the answer is yes, it just packs itself up into a little ball, and then the C++ scheduler can do whatever it needs to do, like, just schedule another one. Yes?
We have about 12 minutes left.
Okay, right. Right, yeah, let's do a demo. So, what are the other things? There are some short-term improvements. Tommy's actually done there's another guy who's contributed mono micro-threading. So instead of doing all this stuff at CIL level, you just do it at the 8086 stack level. So you just split the whole stack to another block of memory. The advantage of that is it's really, really fast. The downside of that is you can't ship it somewhere else. So, it'd be nice to be able to make that mobile, and then it'd be much faster than what we currently have, but we can't currently use it. So we want to, another really easy thing that I've been talking to Miguel about is we want to do GC-supported memory usage queries. So rather than serializing a script to a block of memory just so we can find out its size, we just get the GC to tell us how much memory is reachable from this script. Pardon? I can't hear you, sorry. Mono has its own embedding APIs, and they're really comprehensive and really well documented, so I recommend them. The other thing we could do is explicit assembly unloading. So apparently there is a thing for Mono for this. Yeah.
So when you say packs, you actually take mono source, you pack it, change it, and rebuild it. Yeah.
No, so actually so actually we use standard Mono. We haven't changed it, and all our hacks are above Mono. So Mono's sitting there looking like a proper CLI runtime, and we're doing all this hideous stuff above it and abusing it to make it do the stuff we need to do. But yeah, we could do pretty much all the stuff we do on top of the Microsoft runtime, because we're doing a lot of our crazy stuff is all at the CIL level. So long-term improvements. Build code resource security. It's not enough to be able to say what code am I allowed to run. If you want to build sandboxes out of the CLI, you need to be able to say, this piece of code is allowed to call these methods and these assemblies, but it's also only allowed to use this much memory, or it's only allowed to call this stuff this amount of times. It's only allowed to have this amount of CPU. So if you want to build sandboxes, you need to limit the resources used by code as well as limiting what the code can call. Lightweight mobile threads, because then we won't need hack number 1. Automatic assembly collection, because then we won't need hack number 2. So we could, if the will was there to make the CLI into a great platform for building sandboxes and hosting untrusted code, then you could do this kind of stuff. You can do it now, and we've done it now, but it's a little bit painful. So in the future, clever script scheduling and resource limits determined by landowners, which is what we were talking about before. Questions, is this the right approach? Well, it kind of works. Conclusions, this is a great thing for mono. It's a really good kind of example for mono. It's great for Second Life because we get a decent virtual machine. It's great for Microsoft because when we get to the point where people can run C# and VB and so on, then lots of people who've never programmed before will be using the CLI and will be using Microsoft languages. So if Microsoft want to help us out with piles of money and piles of resources, that would be great. Right. Yeah, or Nobel. Yeah. So there's stuff to contact us at, and then we'll do a quick demo. So how do I?
Magic of technology. You're gonna want that.
Yep.
It's thinking.
Is it going to ask me to log in or?
It was running.
Ah.
Ha.
There we go. Okay, so we're in. Excellent. Right, so this is Second Life. That's my avatar, badge Linden. We've only got 10 minutes, so let's do a quick demo. So the way you create scripts in Second Life, this is actually the first public demo of Mono embedded in Second Life. So we were going to show you the normal Second Life, but it's currently being updated. So this is a test grid. The actual viewer's running in Xcode. This hasn't been tested. It'll probably fail. But here we are. This is the first demo of it. So the way you script stuff, first of all, you need to create yourself an object. So there we go. There's an object. It's a cube. We can move it around. We can stretch it. We can rotate it. We can say, okay, this is physical. Stop editing it. And there we go, it's physical. So that's how you build stuff in Second Life. And everything in Second Life is made up of boxes and stuff like this. So if you want to script it, you go to the content. We go, right, we want a new script. So notice the mono checkbox in the corner. Right? This is the only visible difference between Second Life running mono and Second Life running LSL2, right? So this is the default script. When you create a new script, this is what it says, and it's got an event handler that says, when this script's created, say hello avatar. When this thing's touched, say touched. So just to prove this isn't completely faked, let's say hello Langnet. So we've got mono checked. So if we save it here, we're actually compiling it on the client to CIL assembler. We're shipping it off to the server. Then we're turning it into a CIL assembly. We're injecting microthreads in it. It comes back and says it's complete. So if we close that, if I'm quick enough, hello Langnet, right? So then, because I've got a touch handler, when I hover my mouse over it, I get a finger. If I click it, it says, yay, it's touched. So then, if we edit the script again, and we say, okay, we don't want mono, and we resave it, it's now running on our bytecode interpreter. It says, hello Langnet, and we can touch it. So we've got the two VMs running at the same time at the moment. So let's do something that actually shows the differences between these things. So in my back pocket, I have a script which implements the Fibonacci function. So if I drag that into my object, it says hello avatar now because I didn't change this one. And this time when I touch it, it's going to run the doubly recursive Fibonacci implementation. It's going to spit out the intermediate results. So if I click on it, bang, a load of numbers. Right? Notice fairly quickly. If I now edit the script again and say we don't want to be running on mono, and I resave it. Now remember how fast it was before. So hello avatar, it's restarted. If I click on it, touched. Na 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 na. Hey, number. Whoa, another number. Hey, another number. Yay, some more numbers. So, there you go. I mean, that's the kind of quickest demo I could do of the actual perceivable difference between running this stuff on mono and running stuff in the bytecode assembler. It's just shitloads faster on mono, which is a good thing. So, if we get rid of that, and we stick a new script in, this kind of just shows the sort of things that you can do with your with scripts in Second Life. So now when I touch this object, it's going to animate my avatar. So there we go, striking a number of different poses. Hopefully you can see that. So now he's waving, jumping up and down, falling asleep, doing a backflip. So that's the kind of, yeah, I'll actually show you some of that script so you can see the sort of things you do in Second Life. So we've got, and this is LSL. So this is not C# and this is not VB. So we've got a big long list of all the different animations. When it starts up, it goes, we're going to request permissions from the owner to say, is it okay for me to animate you? Because otherwise there's a fairly horrible opportunity for griefing where you write a script which just animates other people's avatars to do stupid things even if they don't say yes. So then, there's a bunch of other event handlers here. And when we touch it, it's just going to go, have I got the permission to animate an avatar? If I need to, stop the current one, get an animation name out of that big long list we saw at the top, and then say start the animation. And so this script is, as you can see, also running on mono. So we've already integrated, we've already bound all of the LSL functions to be callable from mono scripts. So fairly soon we'll be able to go, okay, you can call .NET Framework library calls from your mono scripts, and you can also call Second Life library stuff from mono scripts. So it's just a couple of examples of scripting in Second Life, and hopefully you can see the advantage, just the raw speed advantage of being able to have a JIT and running this stuff on a proper virtual machine that wasn't developed in a week. And so, yeah, there we go. Here's just a bunch of other stuff made by people in Second Life, and all this stuff was made in the same way that I created that box. Create primitives, stretch them around, nail them together, and you come up with all sorts of crazy stuff. So that's just about it for the demo. Any questions? Yes?
You said the magic word query before. Are you running a relational database as your backstore or something else?
So the objects are all stored as the things like the scripts and the yes, okay. So are we running a relational database at the back end? Yes, we are for things like people's money and their inventory. But the actual objects themselves are stored as files on a big-ass HTTP cluster. So when you log into a simulator, it'll just say you need these bunch of IDs, and then it'll start streaming objects from the HTTP server. How do we limit the CPU usage? So we, as I was describing, we take a CI assembly, we inject this microthreading stuff in, which includes a bunch of calls out to static methods which say, do I need to yield? So it's, and then the result of that, if the result of that do I need to yield is a yes, then the script will pack itself up. So we limit the CPU usage by just effectively giving time slices to each script, and each script is not allowed to infinitely loop, because every time it loops, it will be saying, can I carry on running? And if the answer is no, then it will stop.
Yeah, more broadly, there's a scheduler outside of Mono that's budgeting for physical simulation and network traffic and all those pieces. And basically, the time left over goes to the scripting system. So that's what's getting compared to when the Mono opcodes are popping out to do the check.
Yep. Any more? Yes.
Considering what you have shown, if I understand, you showed actually continuations.
Yes.
Yes?
It's in some ways it's.
Do we need them or not? So probably you heavily rely on them. So one of the features that definitely is missing from current CLR. Yes.
Yeah. So if this, yeah, the question was, aren't we just doing? Okay.
So it's feature of Celera, another unloading domains. Yes, I remember I heard people crying all over the internet about this feature.
Mm-hmm.
Unload the domain, unload the assembly. Yes.
Yep.
So all these features, did you talk to Microsoft, or are you considering talking to Microsoft about adding this as a features of some part of the CLR, so it's no longer text that you have to go for?
Yes, so the question was, aren't we just doing continuations, and isn't assembly unloading really important? And I'd say yes to both those questions. We are using a form of partial continuations, and we're using it for microthreading, which people have done before. If the CLR implemented continuations, we could use that. Yes, that would be great. And isn't this domain unloading stuff horrible? Yes, it is. And it would be lovely if the CLR did it natively. So yeah, I completely agree. It would be much better if we just kind of went to Microsoft and said, these are all the things we want the CLR to do, go and make it happen. And then we wouldn't have to do any of this hacky stuff, and we could all just use it out of the box. So yeah, I mean, I'd love to talk to Microsoft about implementing that stuff and putting it in.
They never talked, and they never considered?
Well, so we talked to...
Obviously, these things, it's not only for you. We heard about continuations before, and I mean, it's all general stuff for scripting and for general. So, you never talk to Microsoft?
No, I mean, the chances of Microsoft kind of going, yes, certainly we'll rewrite the CLR for you and get it to you in 6 months.
To run on Debian.
Yeah, to run on Debian is pretty low. But I agree that these features are generally useful. We're not the only people who really would like to unload assemblies, and we're not the only people who would really like microthreading or continuations. So we're just one of those people, and we'll join the queue, and we're happy to wave banners and talk to people and say this would be a good thing. So we've managed to do it. It would be better if the CLR did it natively, definitely. So one more question, I think.
What is God?
God? God is me.
Okay.
So I'm at Linden, so I get to log into Second Life as a god. It's just an extra menu that allows us to do a bunch of debugging things. Yeah. So I think we got time for one more. That was only a quick one. Oh, we're over time anyway. So thank you very much for listening.